Welcome back, students. In this video, we're going to cover from the Geometry Bootcamp, Station 5. This is Logic and Relationships. Excuse me. So I'll get right into this. I apologize. This is in the middle of the book, so it's not laying flat, so it's going to be a little wobbly. All right, so we're going to start out talking about the P and Q statements. This goes back to Module 3. All right, so anything after if is going to be your P statement, and then anything after then is going to be the Q. And it kind of tells you that. So if I study, then I'll pass the EOC. So I study is going to be your P, or if I study, and I will pass the EOC as your Q. P then Q, if I study, then I'll pass the EOC. That is a conditional statement. So if the first statement's true, then the second statement must be true. All right, and then connection. So if P then Q, that's what that means. And then if Q then R, then P then R. So it's just like the transitive property. So P to Q, Q to R, which means P to R. All right, so I'm going to talk about the inverse. The inverse is the negation of both statements. So it's not P, not Q. So if I don't study, see, negated it up here, it was will, if I study, don't study, so that's the not, then I won't pass, and see, will pass, so that's where you negate. Okay, so if not P, not Q, if I don't study, then I won't pass the EOC, and of course that is the inverse. And I'm going to write this again at the end just because that's how I roll. All right, and the converse is, so we just flip Q and P. We keep them both, we don't negate either one of them. We're just going to say Q, if Q then P, instead of P then Q. So if I pass the EOC, then I will study. The inverse was over here. That was negating P then Q, and then the contrapositive, that's taking not Q, not P. So you negate them both, but you flip them, so it would be, if I do not pass the EOC, then I won't study. So, all right, and we'll flip down here. So biconditional, if a statement is true both ways, so it uses the words if and only if. I know you guys have heard that plenty this year, at least if you've been paying attention, you have. So, if and only if. So if today is Friday, then tomorrow's Saturday. If tomorrow's Saturday, then today's Friday. So, and this is true both ways. All right, so both are true if we write the biconditional today is Friday, if and only if tomorrow is Saturday. So when they're both true, you would write it back like that. That's the logic. All right, now the relationships, angle relationship portions here. So, so when we talk about two parallel lines, in between the lines are going to be the interior. Interior, blah, blah. Let's see how my writing is. So that's the interior. The exterior obviously is outside. Hold on, watch. All right, so yeah, we'll do exterior. So exterior is outside of those two parallel lines. In between them is the interior. We'll just do that. Hang on. All right, so so in this case, so alternate exterior, that's going to be outside the lines and on opposite sides, so 1 and 8. Just going to kind of, so 1 and 8. And then also 2 and 7. Be hard to see that, but you guys get it. So they're alternate, so opposite sides, and then exterior outside those two parallel lines. Alternate interior, so 3 and 6, and 4 and 5. They're opposite sides, or opposite sides, and then they're inside the two parallel lines, so alternate interior. So those are all congruent. Consecutive interior. So that's these two that are directly face each other. Sometimes the consecutive number, like if they numbered them like 1, 2, 3, 4, this would be 4, 5 instead of 3, 5. But so sometimes it works out to be consecutive numbers, but if they're directly, I hate to say across because it confuses us, but if they face each other, these are inside and they face each other, they would be consecutive interior, and they're going to be supplementary. They're going to add up to 180, aka supplementary. Y'all wouldn't, I don't know, Mr. Sobieski did this station. Shout out, Mr. S. But I haven't sat in his class, so there may be things that I say that he didn't. Hopefully, either way, between the two of us, you get something out of that. All right, and then lastly, so corresponding. So this is see 2 and 6. See, I'm just going to put my pen between these. All right, so 1 would be top left, 5 would be top left, 2 would be top right, 6 would be top right. 3. So 3 is the bottom left, 7's the bottom left, and 4 is the bottom right, 8's the bottom right. So those are your corresponding angles, and those also are congruent. So you see 2 and 6, 1 and 5, 3 and 7. Then I'll put over here top right. Hopefully you guys will understand. Remember. So, and 6 and 8. Hopefully you guys get it. All right, we're going to look at the bottom before we flip over. So rise over run, that's your slope. So M, that represents slope. This is on the reference sheet. So you're going to subtract your Y's on top, subtract your X's on bottom. Just remember, wherever you make X1, make that Y1, X2, Y2. And then slope-intercept form is Y equals MX plus B. M is the slope, B is the y-intercept, and Y is the value where the X value is 0. Y-intercept is where the X value is 0. That's where it crosses the Y-axis, so the X is 0 in that point, at that location. Let me try to get it to fold. There we go. All right. So starting up here, number 1, we want to find the values of X, Y, and Z. And my folks know you can't find multiple variables at the same time. We got to find X, then we find Y, or W in this case, and then we find Y. All right, so 2 things. Over here, so anytime you see 2 lines intersect each other and make an X, they create vertical angles. That's what these are. So these are congruent, and like this guy, I'll just call him, anyway, I'll draw a smiley face here and a smiley face here because these 2 are congruent and these 2 are congruent. All right, now, you see, these are vertical angles up here. Don't let the shading fool you. So these are not both congruent. Here, these 2, and watch. So I'm going to take a little Post-it. If I cover this, you see how both of these angles, all this shaded area is a straight line. This is a linear pair. And that E equals 180, or is supplementary. So I'm going to do this. I'm just going to go orange above it, and you'll see that the orange follows the straight line when I remove that. So that's your linear pair rides a straight line. I'm just going to draw a line underneath there. Hopefully that makes sense. But yeah, so opposite sides are congruent on the vertical angles. So those two would be congruent, and then those two would be congruent. All right. So now, I know, so first we're going to, let's see, how are we going to do this? Yeah, so we're going to start y plus 3x minus 15 is going to equal 180. And I know, well, Mr. Whitlock, we can't solve both. Right. We're going to have to, we're going to solve, hold on, how did we do this? Wait a minute, give me just a second. Oh, how? So I see, oh, Mr. S has a given that y is 45. Okay, so that must be something that got left off. So we are given that y equals 45 degrees. Either that or I missed something. If so, sorry, Mr. S. So what we would do, so you'd have 3x minus 15 plus y is going to equal 180, because that's all of this. So they gave us y. So 3x minus 15 plus 45 now equals 180. We're going to have to make room. All right, so 45 and negative 15, or negative 15 plus positive 45 is going to be a positive 30. Oops. And 3x is still here, and 180 is still here. All right, so we're going to subtract the 30 from both sides. That's the inverse, So we cancel there. 3x equals 180 minus 30, which is 150. Now we divide both sides by 3. So it's 3x equaled 150. So now x equals 150 divided by 3. So x equals 50. So it really wasn't. It was just give them these two with this given, I guess. Mr. Sobieski will correct me later. All right, so these two are equal to one another, and now we know what x is. So it would have been, so x minus 5 equals w. We now know that x is 50. So 50 minus 5 equals w. 50 minus 5 is 45. So w is going to equal 45 as well. And then let's look at this. So remember, these two equal 180. So this is 45. 3 times 50 is 150. 150 minus 15 is 135. And then 135 plus 45 makes 180. So hopefully we got all that. All right. Number 2, find the slope and y-intercept. So y equals mx plus b. Remember, m is beside the x. So right here, our slope is going to be 3. The y-intercept's out here on the end. That's a positive 9. So our slope is 3, and our y-intercept is positive 9. All right, number 3 right here, write an equation of a line that goes through points, or goes through this point and has this slope. So we want it in y equals mx plus b form. Our m is 2. Let's see. The way you find the y-intercept is you go ahead and plug in your x and y. So we have x is 3 and y is 2. So, and then slope was 2. So 2 is our slope. X is 3. We were looking for the y-intercept, or b. And then the y we plug in out here is 2. All right, so 2 times 3 is 6, right? Plus b is going to equal 2. Well, we're going to subtract 6 from both sides. That's going to give you b equals, and it should be negative 4 left over. All right, so now we have our m, our slope. We have our y-intercept. So it's just y equals m is 2, x plus, well, not plus b because it's a negative, so it's 2x minus 4. Y equals 2x minus 4. All right. So same thing here. This time they don't give you the slope, but they give you 2 points. So to find the slope, we look on the reference sheet, and you'll see that the slope is the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Like I told you guys, it doesn't matter. I like to work left to right, so I would make my x1, y1 over here on the left and my x2, y2 over there. Hopefully you can see that. All right, so 10 minus 2 on the top, and then 8 minus 4 on the bottom. So 10 minus 2 is 8. 8 minus 4 is 4. And that gives us a slope of 8 over 4, which is 2. All right, so now we're going to plug in. You can plug in either point. Let's do it over here. Y. So we know y equals mx plus b. I know mine looks like a 6, and I apologize. So we're going to plug in x and y. We'll just use 2 and 4. So 2 equals 2 times our x is 4 plus b. So 4 times 2 is 8 plus b equals 2. Subtract, and your b is going to be 2 minus 8, which is negative 6. So it's going to be y equals mx plus minus b, because plus b, but it's a negative, so it's minus b. Okay. All right, number 5. If it rains, then it floods. P, Q. All right, so what's the conclusion? The conclusion is the Q. So if it rains, it will flood. They tell us it rains. What's the conclusion? It floods. Because it rained, or because it rains, it floods. All right, bottom of the page and the end of this station. Sorry, guys, I know I told you, excuse me, I was going to have this done by Saturday, but I have not felt well, and it's been a long kind of weekend. So let's finish this up. So everything after if is the P, everything after then is the Q. So remember the converse. Converse is Q then P. So if P is if a shape has 3 sides, then it's a triangle. So our Q then P, or our converse, would be if a shape is a triangle, then it has 3 sides. We'll abbreviate where we can. All right, so the inverse, that's not P, not Q, not P, not Q. So if a shape does not have 3 sides, then it is not a triangle. Okay, so we've got not, because there. Contrapositive, not Q, not P. So if, I'm going to just put it is not a triangle, then we're just cutting the shape part out. It does not have 3 sides. So 3 sides was the P, triangle was the Q. So this was Q then P, not Q, not P, not P, not Q. Is the biconditional possible? And it's yes, because if it's a triangle, it's going to have 3 sides. If it doesn't have 3 sides, then it's not a triangle. And if it's not a triangle, it's not going to have 3 sides. A triangle is very specific. Anything more than 3, 4, that's a quadrilateral. You can't say every quadrilateral is a parallelogram or whatever. But you can say that for a triangle. And so if our biconditional, so if a shape, no, not if a shape, sorry, we take the if out of them. So a shape has 3 sides if and only if it's a triangle. All right. That is it for this video. This concludes Station 5. I'll be back soon with the next station. Until next time, have a good night.